When you spot a bright, steady light in the night sky, it might not be a star at all. It could be a planet shining back at you from millions of kilometers away. Unlike stars, which twinkle, planets often glow with a steady, unwavering light. These wandering points of light have fascinated skywatchers for centuries, and some of the brightest are our solar system's giants. Maybe you're looking at Jupiter or Saturn, two of the most spectacular planets visible to the naked eye. Their brightness and size make them stand out, even from our distant vantage point on Earth. These are the gas giants, enormous worlds made almost entirely of hydrogen and helium, swirling with thick clouds and powerful storms. They're nothing like our small, rocky Earth, and their sheer scale is hard to imagine. Jupiter is so massive that all the other planets in the solar system could fit inside it. Its swirling atmosphere is home to the Great Red Spot, a gigantic storm that's been raging for centuries, so large it could swallow Earth whole. Saturn, on the other hand, is famous for its breathtaking rings, vast bands of ice and rock that encircle the planet in a dazzling display. Amazingly, Saturn is less dense than water, so if you could find a bathtub big enough, it would float. By studying these giant planets, scientists gain valuable insights into how planets form and change over time. Their complex atmospheres and magnetic fields offer clues about the early days of our solar system, and even about planets orbiting distant stars. Their immense size and unique chemistry make them like natural laboratories in space, helping us understand the many different ways planets can be built and what makes each one unique. Yet, for all we've learned, some of the biggest mysteries come from what we can't see, like a missing element in their atmospheres that left scientists scratching their heads for years, searching for answers. And that brings us to a cosmic game of hide-and-seek, where the universe still holds secrets waiting to be discovered. The mystery at hand? Silicon, a common element on Earth and throughout the universe, seemed to be missing from the atmospheres of Jupiter and Saturn, two of our solar system's largest and most intriguing planets. This was a puzzle that left astronomers scratching their heads because silicon is supposed to be everywhere. Scientists expected to find it easily since silicon is a building block of so many things. It's in the sand beneath our feet, the rocks that make up mountains, and even the microchips powering your phone and computer. It's one of the most abundant elements on Earth, and it's forged in the hearts of stars. But when astronomers pointed their powerful telescopes at Jupiter and Saturn, they found almost no trace of silicon in the upper atmospheres of these massive gas giants. The expected chemical fingerprints were simply missing, defying predictions. So, where did all the silicon go? The leading theory suggests that silicon atoms bonded with oxygen to form tiny silicate particles. These particles, heavier than the surrounding gases, would have gradually sunk deep into the planets, vanishing from the layers we can observe. These heavy rocky clouds would be hidden far below the visible atmosphere, buried in the planet's deep, dense layers, completely out of reach for our instruments and invisible to our telescopes. Proving this theory was incredibly tough. No probe ever sent to Jupiter or Saturn could survive a journey that deep into the crushing, turbulent clouds. The technology just wasn't there. So, scientists realized they needed a new approach. They had to look beyond our solar system, searching for a place in the universe where the conditions might be different, and where silicon wouldn't be hidden away. That's when a powerful new telescope entered the story, offering a fresh set of eyes and the ability to peer deeper into the cosmos than ever before. The search for answers was about to go cosmic, opening up a whole new chapter in our quest to solve the case of the missing silicon. Enter NASA's James Webb Space Telescope, an infrared powerhouse that can read the chemical barcodes of distant worlds. By analyzing the heat signatures from far-off objects, Webb reveals what their atmospheres are made of. Scientists, led by researcher Faherty, needed a control group, a gas giant-like object formed in a different environment. They searched for a world that might have formed with less oxygen, to see if silicon would show up differently. Their quest led to a strange object, not a planet, not a star, but something in between. This oddball, nicknamed the Accident, was the perfect test case. With Webb's powerful eye, scientists were ready to crack the silicon mystery wide open. The cosmic detective story was about to get its big break. The Accident is what astronomers call a brown dwarf, a so-called failed star, that sits in a strange middle ground. It has more mass than a planet, but not quite enough to ignite the nuclear fusion that makes true stars shine. Instead, it drifts through space, forever caught between two destinies, never able to become a full-fledged star. Brown dwarfs like the accident glow only faintly, radiating the leftover heat from their formation. This makes them incredibly difficult to spot with ordinary telescopes, as they barely emit any visible light. Yet their dim glow in the infrared spectrum makes them perfect targets for astronomers who want to study the atmospheres of objects that are neither planets nor stars. The accident was discovered in 2020 by a dedicated citizen scientist who was carefully scanning through years of old NASA telescope data, searching for objects that moved against the background of distant stars. This remarkable find was a testament to the power of curiosity and perseverance in science. Located about 50 light-years from Earth, the accident is not just any brown dwarf, it's one of the oldest ever discovered, believed to have formed between 10 and 12 billion years ago, when the universe itself was still young and galaxies were just beginning to take shape. In those ancient times, the universe was a very different place. There was almost no oxygen, just vast clouds of hydrogen and helium, the simplest and most abundant elements swirling through the cosmos. This oxygen-poor environment made the accident a truly unique laboratory for astronomers. It offered a rare opportunity to test the missing silicon theory, which suggests that certain elements might be hidden or locked away in unexpected places within these ancient objects. If silicon wasn't hiding in the accident's atmosphere, then perhaps, for the first time, scientists could finally catch a glimpse of this elusive element and understand its cosmic journey. The stage was set for a scientific breakthrough, with astronomers around the world waiting in anticipation for answers that could change our understanding of the universe. With the powerful gaze of the James Webb Space Telescope, humanity was about to peer back billions of years and uncover secrets that had been hidden since the dawn of time. Scientists aimed the Webb telescope at the accident and analyzed its faint infrared light. They found something remarkable: the clear signature of silane, a molecule made of silicon and hydrogen, SiH4. Unlike Jupiter and Saturn, where silicon is hidden deep inside, here it floated in the upper atmosphere, easy to detect. The missing element wasn't missing at all. It just wore a different chemical disguise. This discovery proved that in an oxygen-poor environment, silicon bonds with hydrogen instead of oxygen. The accident's atmosphere became a window into the early universe, showing what gas giants might look like in a different era. The Webb telescope's detection of silane confirmed the theory. Oxygen's presence determines whether silicon hides or shines. The puzzle was finally solved. Comparing the accident to Jupiter and Saturn reveals the power of time and chemistry. The accident formed when the universe was young and oxygen was scarce, so silicon bonded with hydrogen, creating silane gas. Billions of years later, our solar system formed in an oxygen-rich galaxy. Here, silicon quickly bonded with oxygen, forming silicate rocks that sank deep into gas giants, hiding from view. The accident acts as a chemical fossil, preserving the conditions of the early universe. Jupiter and Saturn, by contrast, are products of a more mature, oxygen-rich cosmos. The Webb discovery confirms the fate of silicon depends on the cosmic environment at birth. It's a story of chemistry, time, and the evolution of worlds. And it all comes down to a cosmic competition. Oxygen wins if it's around. So why does this matter? Solving the silicon mystery helps us understand how planets form, here and across the universe. It shows that the chemistry of a world depends on when and where it was born. This knowledge helps us predict what distant exoplanets might be like, expanding our sense of what's possible. The story began with a curious citizen scientist and ended with a global team using cutting-edge technology. It's a reminder that anyone can contribute to science and that big discoveries often start with simple questions. By studying distant worlds, we learn about our own origins. The elements in our bodies were forged in ancient stars. Every time we look up, we're connecting with the grand story of the cosmos. And there are still countless mysteries waiting to be solved. Keep looking up.